Friends, in high school you studied pendulum. In 11th and 12th standards you studied pendulum. In engineering you have this pendulum in your some chapters. So what is this pendulum? Why is so important that everywhere we are studying pendulum? And two types of pendulums. One is a conical pendulum, another one is simple pendulum. What exactly the difference between them? That is what I am going to discuss in this video. In case of simple pendulum, the bob of simple pendulum moves to and fro motion in a curved path as shown in the figure. And in case of conical pendulum, the bob of conical pendulum moves in horizontal circle. The path AMB is called as trajectory of simple pendulum. It is moving between two extreme positions A and B. M is the mean position. It always crosses mean position, moving through the two extreme positions. The trajectory of the bob of simple pendulum and motion of the bob of simple pendulum can be considered as the part of vertical circular motion. Implies the path AMB of the bob is nothing but a part of vertical circular motion. And in case of conical pendulum, trajectory of the bob of conical pendulum is horizontal circle. Even the plane of motion of the bob of conical pendulum is horizontal circle as shown here. Next thing, let us understand that the theta is nothing but called as the angular amplitude, and L is called as the length of conical pendulum. The length of conical pendulum will not change. It will remain the same. But as the angular amplitude increases, that is theta increases, then the radius of that horizontal circle keep on increasing. And this horizontal circle will move from bottom to top, from lower end to upper end. So as the angular amplitude of the conical pendulum increases, horizontal circle also, the size of a horizontal circle also increases, and the circle moves in the upward direction. Now let us talk about the period of both the pendulums. In case of conical pendulum, the period of oscillation depends upon three factors. These are the length of conical pendulum, angular amplitude, that is theta, and also depends upon gravitational acceleration. The period of both pendulums depends upon gravitational acceleration. This is a common factor. The period of conical pendulum is given by expression T equals to 2 pi under root of L cos theta divided by G. Now, in case of simple pendulum, the period of oscillation depends upon only two factors. These are the length of simple pendulum and gravitational acceleration. An expression for period of simple pendulum is given by T equals to 2 pi under root of L divided by G. So the basic difference of period for both conical pendulum and simple pendulum differed by only cos theta. In case of conical pendulum, L cos theta, and in case of simple pendulum, only L. There is no cos theta. Now the next question, why to study simple pendulum? The very basic and very traditional use of simple pendulum in design of clocks. These clocks have the swinging pendulum. This is very basic and common and traditional use of simple pendulum. The another use of simple pendulum is seismometers. This seismometer is based upon the principles of simple pendulum, also depending upon the concept of inertia. During earthquake, the frame of this seismometer can shake, but the pendulum and the bob remain vertical. It doesn't move, but the frame can shake, and a paper is attached to the shaking frame, and at the end of this bob there is a pen arrangement. So as the frame is shaking, which is already attached with the paper, so it can draw the graph. It can draw the pattern of earthquake. It can draw the pattern of seismic wave. And this graph is called as a seismograph. So this is another important use of simple pendulum. Now, let us talk about what are the different applications of conical pendulum. The very important and very common application of conical pendulum in amusement park. The swing rides, not all swing rides, but some as shown here in this figure. There we use the concept of conical pendulum. In this type of swing rides, there is a central tower. As the central tower is spinning, the passengers also spinning in outward and upward direction, and that creates the uniform circular motion, and the riders sitting in their seats traces out inverted cone, so which is nothing but as good as the motion of conical pendulum. So this is the common observation, common application of conical pendulum. Can you guess what is this game? This game is called teeterball sport. Even in this sport, we observe the phenomena of conical pendulum. Even in case of aircraft banking, the concepts of conical pendulums are involved. Friends, physics is very easy subject, provided you understand it in a common language. If you have any such topics, if you have any such difficulties in physics, please do not hesitate to contact me. Write down your difficulties in message box. So meet you again with next topic. Till then, wish you good luck, all the best.